All right, we are Math 200. We're doing the review, second review, review 2 for chapters 3 and 4. Graphing, mostly graphing. So, problem number 1, graph. They want us to use 3 points, so we're going to pick some simple x's and y's. You pick like 0, 1, and 2. That's fine. You put in 0, 2 times 0 plus 3, that's 0 plus 3, that's 3. So that's what y equals. When x is 0, y is 3. So 0, comma 3 is a point on the graph. Pop in a 1. 2 times 1 is 2, plus 3 is 5. So y is 5 when x is 1. 5. And then you pop in a 2 or a negative 1 or whatever you want. It's fine. 2 times 2 plus 3, that's 4 plus 3, that's 7. So 2, 5, 6, 7. And then connect the dots and make sure you put arrows in the end. Don't forget the arrows. Although you won't have to because you're doing it in Newton and it'll have the arrows on there ready for you. All right, so graph the equation y equals negative 2x minus 1 by plotting points. So again, x, y, we pop in 0, we pop in 1, we pop in 2, or whatever you want. You can do negative 1, you can do negative 2, 0, that zeroes out, you get negative 1. 1, that's negative 2 times 1 minus 1. That is negative 2 minus 1, that is negative 3. And pop in a 2, that's negative 2 times 2 minus 1, that's negative 4 minus 1, it's negative 5. So y is equal to negative 5. So now we got 0, negative 1, that's right there on our graph. We got 1, negative 3, that's right there on the graph, and we got 2, negative 5 there in the graph, and then connect the dots, put the arrows on. Again, take a look at the difference. This has a positive slope. It started at 3. If you wanted to graph it by using a slope, you would have went up 2 and over 1, up 2 and over 1. You would have got the same graph. Same with this one. Could have started at negative 1, went down 2 and over 1, down 2 and over 1. We would have got the same 3 points. So keep that in mind when you're doing the test on Newton. Let's go to page 2. So some of these problems are really fast, but some of them take a really long time, like those ordered triple ones. Those are a little intense. Those take a little bit of time. All right. So x is equal to 2. Graph that you don't really have to pick points, it's a vertical line through 2. That's it. That's the graph. All right, number 4, negative x minus 3y equals 6. This time they want me to find the slope and the y-intercept. And so that means we have to do some solving here. Graph eventually. So add 1x to both sides. So you get negative 3y is equal to 1x plus 6. Divide everything by negative 3. You got y is equal to negative 1/3 x minus 2. Now pull the slope out. That's negative 1/3. That means down 1 and to the right 3. And then the intercept is negative 2, so that's 0, negative 2. So I put a dot on negative 2 on the y-axis, and from that point I go down 1 and over 3. So from here, down 1 and over 3, and then I connect the dots. So a little easier than when on the page before where we were plug and chug. All right, and then the last one on this page, page 2, is number 5. They give us 2 points and tell us to find the slope. Well, the slope formula is the change in y over the change in x. So that's y2, here, x1, y1, x sub 2, y sub 2. This one, -6, minus that one, minus -6, over this one, -8, minus that one, minus -4. Oh, too many minus negatives. Remember, 2 negatives make a positive, so -6 plus 6 over -8 plus 4. That is 0 over -4. That is not undefined. That is a slope of 0. If you forget which one is undefined and which one is 0, use your calculator. Go ahead and pop that in your calculator. 0 divided by -4 is 0. If it's the other way around, like 5 divided by 0, your calculator will tell you error. And then you know that's undefined. All right. Let's look at number 6. Again, this review, I did it just like the test. So it's randomized, so it's not in like the easiest to the hardest order. So sometimes we'll get a really tough one in there, or sometimes it'll be, on the last page, it's a super easy one. So look at page 3 on the review, the written review, and they want us to graph an inequality, which is a little tougher, because we're going to have some shading to do. So first isolate the y, so plus 2x. So y is less than 2x minus 2. Now pull the slope out, it's 2 over 1. Pull this intercept out, that's -2. So 0, -2 is the y-intercept. So that's my starting point. I put a dot there. From there I go up 2 and over 1. Put another dot. And again, if you want, you can go up 2 and over 1, up 2 and over 1. Now, when it's greater than or less than, that means a dashed line. That means the line divides all the points that work against all the points that don't work. It does not include the points on the line. It's a boundary. It's not an inclusive boundary. All right, if it's less than or equal to or greater than or equal to, then you get a solid line. And now less than. So think of it, if you tilt it like this and make it exactly, a horizontal line, this would be less than, this would be greater than. When it's got a slight askew, it's very likely, this is going to be the part we're shading, this is the less than side, because y is less than 2x minus 2. But if you're unsure, you can always test 0, 0. Now, in this case, when we put 0, 0 in, it should fail. It should make an untrue statement, because we're shading all the other side of it. So if I put 0 in for y and 0 in for x, I get this statement, 0 is less than -2. Well, that's false. 0 is greater than -2. So this fails. So this point fails, every point on this side of the line fails, and every point on the other side works. Lots of people don't even need to do this test because they just have a good spatial sense, like what's above and what's below, less than or greater than. So either way, you can test it if you want to. All right, so 7, determine if this is a function. Yes, that is a function. That is a parabola. There's never one point directly above another point. If I draw vertical lines, it'll only ever hit it in one spot. That means it is a function. All right, number 8. We got -x plus y is equal to -2. And we got -2x minus 5y is equal to -11. And so you can solve this in any way you want. If you want, you could use substitution. I think I'm going to solve it by using elimination. I just think that's the easiest one. So I'll tell you what, I got rid of the y's on the key. So this time I'll do it a little differently. I'll get rid of the x's. So if I want to get rid of the x's, this one is -2x, and that's minus 5y, and that's -11. So if I multiply the top by -2, because they're both negatives, And everything gets a negative 2 multiplied. So that becomes positive 2x. Now that'll go away. Negative 2y and positive 4. And now I add straight down and look at what happens. My x's are now gone. And I got negative 7y is equal to negative 7. Divide by negative 7 and solve for y is 1. So if y is 1, I want to now find x. So I take that and I put it back into either one of those equations. Looks like the top one's maybe a little easier. So instead of writing negative x plus y equals negative 2, I sub in my 1 for y, and now I solve this equation. We're back to week 1. We're solving equations. 3. So without actually graphing it, we figured out where they cross. They cross at 3, 1. That is the point of intersection between this line and that line. And you can check it back. If I put 3 in there, that's negative 3 plus 1, that's negative 2. Put 3 in there, that's negative 6 minus 5, that's negative 11. So it checks out algebraically. That is page 3. Let's take a look at page 4. All right, well, we like number 9. Geez. Find the point of intersection, but the line's already graphed. So that's just tell me where they cross. So they cross at 2, 1, 2, 3, 4, 5. 2, 5. That's it. So that one, you just have to know how to figure out the coordinates, right? X is first, y is second. Don't mix that up. Don't trip it on the easy ones. All right, number 10. X minus 4y equals 12, and x plus 3y equals negative 16. So I'll tell you what, this time I'll do substitution. On the key, I did elimination again, but we just demonstrated an elimination problem. So, and there's no reason you don't have to do elimination every time. So on the review, I multiplied everything by negative 1 here. Add straight down, the x's went away, solve for y, put it back in. What does substitution look like? Well, that you solve. In this case, I would solve for x. You pick the easiest thing to solve for. X is super easy to solve for. So you add 4y to both sides, and you get x is equal to 4y plus 12. And it's already solved out, so I don't have to worry about dividing by anything. It's already solved for x. Now, we take that 4y plus 12 and we stick it back into the other equation. So we get this, 4y plus 12, where the x used to be, but then still plus 3y equals negative 16. So we just replaced the x with 4y plus 12. Why would we do such a thing? Well, we tricked it out to be one variable. That's exactly what we're doing when we do the elimination method. We're tricking it out to be a single variable. All right? So now we get combine like terms. 7y plus 12 is equal to negative 16. Isolate the variable, subtract 12 from both sides. 7y is equal to negative 28. Divide by 7, and whammo, we got one of our answers, negative 4. Now, this is the advantage to the substitution method, is after you find that, finding x is super easy because it's already solved for x. So it's just a plug and chug kind of thing. So, negative 4 is the point of intersection. So again, I found out where two lines cross without actually graphing either one of the lines. All right? And then, solve another one. Okay, so this one is designed for substitution. So that one I did with substitution. The next one on this page is kind of designed for substitution. And so let's take a look at that one. And now what do I mean by designed for substitution? Well, look, it's already solved for y. And so we're going to take this and sub it in where the y is, all right? So we're going to have 5x plus 3 times equals negative 3. So instead of y there, I'm going to sneak in a negative 2x minus 3. And look at what that does. We get 5x minus 6x minus 9, right? Equals negative 3. And now I combine my terms. Negative 1x minus 9 equals negative 3. I isolate the variable, get x all by itself. Negative 1x equals 6. Divide by negative 1. X is equal to negative 6. And then again, it's super easy to find the y because you're just taking that x and cranking it in there. So 12 minus 3 is 9. So negative 6 comma 9 is the point of intersection. And again, I found that without even graphing. All right. The next video will be the rest of the review.